Seth Levine from Loris.ai, and also, yeah, he has a cool podcast in which he also talks about machine learning and yeah, he talks with very interesting people in this podcast. We like, yeah, Lewis Tunstall from Hugging Face or Sebastian Ratza from Lightning AI. So yeah, very cool podcast. And today he will be talking about Loris.ai, the company in which he works, and how they are using Argilla, and also about, yeah, some NLP challenges and how they using, yeah, Argilla to quickly, yeah, annotate dataset and validate models. Yeah, whenever you want, Seth, you can start.
Okay, sure. I'll share my screen. Okay, hopefully this works. Everyone can see the screen.
Yeah, we can see it.
Okay, great. First off, I have to address the elephant in the room. I call it Argilla. I hope everyone's okay with that. If I tried to say Argilla, I don't know, I would probably mess up a couple times. But anyway, thank you guys for this opportunity. Me and the whole Loris team have an enormous amount of gratitude for you guys putting together, creating this incredible annotation tool. At this point, we have hundreds of data sets. It's helped us train and evaluate easily dozens of models. I initially experimented with Argilla when it was still called Rubrics, so a little while ago. I started experimenting with the tool locally, got a Docker up and running. Then a few months later, I had an experimental data set on Hugging Face spaces, and now our entire data science team and most of the company is familiar with Argilla. And the amazing thing is I feel like I'm still just scratching the surface and we're still unlocking even more value. Yeah, so my name's Seth Levine. I'm the lead machine learning scientist at Loris. I joined Loris back in 2019. We were a team of 5 back then. We're now, I think, around 40 or so. And as Gabriel mentioned, I'm the creator and host of Learning from Machine Learning, a podcast which probably most people here would enjoy. I started that a little over a year ago. So today I wanted to talk about, just what is Loris? What are the NLP and ML challenges we face? How we use topic modeling to support supervised learning. Of course, how we use Argilla. Text classification using SetFit. It's nice to have Tom Arson here, the maintainer. It's how we do evaluation and time permitting, and maybe some thresholding, and then we'll wrap up. So what is Loris? Yeah, we're a company. We started in 2018. We have a lot of great clients, Bill and Slice and Fiverr, Mint and BarkBox. And we started working with companies that help other companies do their customer service. I'll get more into it. We've analyzed over 200 million interactions. We're on 12 countries, over 6 continents. We have tens of thousands of users. And companies have hundreds of thousands of interactions with their customers. And it's one of their greatest assets, and it's one of the most underutilized things. There's billions of customer interactions that contain a gold mine of untouched insights. And they try to get information out of this using surveys, but you might get 5, 10% on surveys. Surveys are biased. There's a selection bias. You're only going to be getting the extremes. So we use AI to transform every customer interaction into an opportunity for insights, optimization, and growth. So we're improving the quality of customer service conversations with machine learning to make customer support more human, empathetic, and scalable. And yeah, Loris basically gives companies the tools to extract gold from this gold mine. Loris's approach. So yeah, the state of machine learning right now, foundation models have basically taken everyone by storm, but they're becoming a commodity, right? Everyone is getting access to it. It's become totally socialized. People are talking about it on LinkedIn. It's like very trending right now. People can get up and running very quickly, but it's much more than just being able to create a model. The challenge is modeling a domain to solve its specific problems. You want to gather the right data. That's the real differentiator. And that's where Argilla comes in, having the right labeled data. So we want to model the domain of customer service. So understand the phases of a conversation, the dialogue acts. I'll get into that later. We use proprietary data to optimize models for customer support. So we have our own proprietary customer sentiment model that tries to figure out satisfaction in real time. We have a conversation markers model, understanding key moments in the conversation. We develop custom models, what we call contact drivers, the reason that the customer is contacting the company. And key here is that we enable a feedback loop on how users interact with our product and the predictions. So we want to be establishing a system where information about our user behaviors and their outcomes is collected and analyzed and used to improve the product and the accuracy of its predictions over time. This is essential for ensuring that the product remains accurate and relevant and responsive to the needs of our users. So this is what the flywheel looks like. Our approach is that you want to combine the best of humans and machines. Machines don't get tired. So if you look in the top right where there's the one, we do an automated voice of the customer. So we're extracting intents and sentiments and reasons to review conversations so we could look at trends. We automate assessment. We assign outcomes and a conversation quality score to every conversation. Where we started was actually real-time agent assist, delivering recommended content and workflows and next steps in live agent conversations. And taking all of this data, we allow humans, CX leaders, to get insights out of what they're doing, to do post-conversation agent coaching, and to improve workflows. And all in all, we're creating this conversation intelligence layer on top of all of the interactions between customers and the company. And in turn, this allows companies to improve their customer experience, their operational efficiency, and their insights. This is a cool GIF that I created. It's showing how back in the beginning of 2021, we had about 1 million conversations. And towards the end of 2023, we had over 200 million customer care messages analyzed. And we're currently, I think it's even more than this, analyzing over 5 million messages per month. So our platform is scaling fast. We have so much data, honestly, more data than we know what to do with, which is a great problem to have. One of the exciting but also really challenging things is that we're omni-channel, meaning that we deal with all the ways that a customer will contact a company. So that's through chats, emails, messaging apps, and as of about a year ago, we incorporated voice. The challenges of dealing with voice, I could probably do a whole talk on, particularly using voice transcripts is not an easy task. But fortunately, even with the challenges that transcripts and something called diarization, assigning who's speaking at what time, and segmenting all of those messages, a lot of the models that we have work extremely well, especially on the aggregate level. Okay, I'll keep getting through here. Now, getting into the machine learning and NLP at Loris. How have ChatGPT-like models changed our approach? You could see the machine learning world has been captivated by generative models, and absolutely for good reason. It's incredible what they can do, and it's revolutionizing our workflows, as you will see. But in industry, there's still an enormous amount of value from information extraction and traditional NLP techniques. Companies need to be able to classify and categorize their conversations. While generative models are great and provide great outputs and achieve incredible results on benchmarks, they're still slow for real time. There's all the problems that we know that they have with retrieving the right documents, with trying to make predictions in real time, still have the ability to hallucinate and cause problems. You've seen companies that have tried to really rely on generative models and really have led to failure and not good situations there. And I think that the problem, which is also the interesting thing, is that it's very easy to create an amazing demo using generative models. It's hard to get something into production, and it's even harder to deliver it at scale. The ease of the approach might be tempting. And you could run into an issue basically where what your users are willing to pay you for it is not as much as what it costs you to run your service on top of large language models. So it's important to understand these trade-offs. And for Loris, we use generative models. We have them in production, of course. For some problems, you need to use that. But a lot of things for offline analysis in a limited capacity where it's helping us label things, helping us with our annotation, helping augment the work that we're doing. Talking about modeling the customer service domain, there's three main questions. How's the customer feeling? We address this using customer satisfaction and our sentiment model. Why did the customer contact the company? We address this using our contact driver or intent classification model, and that's what I'm going to be focusing on later on in the talk. And if you understand how they're feeling and you understand why they contacted the customer or why the customer contacted the company, it's important to understand how did the conversation go and to get an outcome. You can then do a lot of very interesting things. You could do sequence analysis, and you can understand what patterns lead to good outcomes and what patterns lead to bad outcomes. And if you can answer and get better at answering these three questions, you can support all of the things that Loris is trying to do with real-time agent assist, extracting insights, and doing QA. Another model that supports all of these really is our dialogue act classification. And dialogue acts are the role that every message is playing in a conversation. And this is a super fascinating field. It's been around for decades, and being able to apply this and use it to improve the outputs of our model has proved very successful. Okay, getting into some of the more nitty-gritty stuff. These are just these are the main models that we're using in production. So we have our sentiment model. This is a 5-point scale from very dissatisfied to very satisfied. If you think about in a chat conversation, every message that's coming in, we're assigning it between -2 and a +2 score. Sentiment target, while you can understand the score, it's also important to understand what it's directed towards. And for our domain, they want to understand if the sentiment is being directed towards the company or directed towards the agent, right? Are they angry with how the agent is interacting with them, or are they angry about some company policy? Conversation markers, that's a combination of dialogue acts and important moments in these interactions. We also have a profanity model, something we call polite refusal, a question detection model, and these are the ones that I could remember when I was making these slides. We probably have a bunch more. Conversation level, we assign something called conversation quality, CQ. It's a 1 to 5 star outcome based off of a proxy basically for customer satisfaction. It's understanding the trajectory of the customer's satisfaction journey. We have a summarizer. We try to predict resolution, and we try to understand the actions of the agent throughout the conversation. These are our generalized models. So these are things that we can use across all of our clients. This is in comparison to our custom models. We have client-specific text classification models that each client can use to understand their customer's reason for contact. I'm going to use contact driver and intent interchangeably. And why? It's because that's how our clients are. One client will call it intent, another one will call it contact driver, another one will call it submission reason. So it's easier to just give myself some leeway and let me say them interchangeably. In reality, it doesn't matter what you call it. It's just about creating a valuable classifier for our clients so they can better label and segment their data. Before you get into the creation of any model, the most important thing is to really define your objective. And in order to do that, you need to understand what your underlying need is. What problem are we trying to solve? So I'm going to dive into this contact driver or intent problem for probably the remainder of the talk. And we're going to figure out what are we trying to get to. So we want to identify what the conversation is about and understand a company's contact drivers. So there's actually two problems here. First, we need to discover what are the potential classes And then we need to be able to take in a new text and assign it to a class. And why? This is going to give them a meaningful way to segment their data. It can allow them to create workflows for different incoming messages, and it gives you the ability to interpret what a customer is looking for, no matter how they word the request. If they're using different terminology, if there's some typos, broken grammar, you still just want to understand what are they talking about, what do they want to accomplish. And some of the cool things you can do is that the company can then analyze trends, can route properly. So that's like when the message comes in, you want to get it to the right team, and you can create and improve workflows. So something that's really cool, just to quickly show a use case here. So this is for a subscription service, and you see a trend over time, the percentage of incoming messages that are about auto renewal and cancel subscription. And you can see a spike on January 1st and February 1st. And the reason for that is because it's a subscription-based service, and it's the first of the month, and that's when the bill comes in. So that's when people are questioning their auto renewal and questioning their cancel subscription. Similarly, you see here a spike on the third week of the month, so just about around December 20th and around January 21st. This is for order mishap. So for this subscription service, that's when the package comes. So that's when they're going to be complaining that there's missing items, that the box was damaged, etc. So it's very validating when you create a model and then you get these as your outputs, because you're seeing this is working. This is showing something at scale that can be used to show these trends over time. Okay, moving into how we use topic modeling to support text classification. So I'm going to explain this on sort of different levels of abstraction. Here, I'm representing this visually. If you had any sort of problem, you can have this chaotic incoming messages where there's no structure to the data. You can use different algorithms to sort them somehow. For text, you use some sort of topic modeling, and you find some structure in the data, and you give the humans some weak labels, basically, and you can highlight, hey, this is what the human should pay attention to. It's important and necessary to have the human in the loop, and it's important to maximize the impact of the human's time. So going into the specific problem even more, this is what you wish the process looked like. You wish it was this easy, that you could just discover and determine the categories. This would lead to then collecting training data and collecting validated samples. You would then have the labeled data that you would need to train a model. You would evaluate that model, and then you would deploy it, you put it into production, and you never have to think about it again. Never, that's never the case. So maybe, it's like a cyclic process, and you think about, okay, how are you going to evaluate the model? You want to look at it both on the message level. So each individual message that comes in, you want to be able to evaluate and understand, is it predicting the right class? But then also, these things are happening on another level. They're happening on what they call the ticket or the conversation level. And you want to be able to understand the intents of that conversation. And then in actuality, when you put a model into production, you monitor it. But it's not even this simple. In actuality, it looks more like this. And the steps start to blend together. So you could think about when you evaluate and you do error analysis, and you look at something like a confusion matrix, and wow, these two classes are totally confused. Maybe these two classes should be merged. So you're going from the evaluation step back to the discovery stage. That affects what your training data should be. After deployment, something changes in the business and coverage drops and there's data drift and you need to add a new class. So you're going from monitoring back to discovery, and there's all of these things that can happen. And it's important to understand that every step of the state, every step of this process, you always need to be questioning it, and you always need to understand, like, where should I go from here? And often you have to bounce from place to place. Speaking of evaluation, So as I was saying before, there's coverage. You have all of these conversations. There's hundreds of thousands of conversations coming in. What's the percentage of conversations that you're just even assigning an intent for? It's important, right? If you created a model and you're only assigning intent for 20% of conversations, are you providing value to the company? Probably not. They need a number around 70 or 80% coverage in order for it to be meaningful. You can also look at precision. So this is the fraction of the detected intents that are correctly predicted. Basically, when you make a prediction, is it correct? And this needs to be examined on the class level. It's important to understand where you're creating a multi-class classifier. You have to understand how each class is working. You can also look at frequency. So in historical data, does the frequency of each contact driver make sense to the clients? So going back to that trend over time for that subscription service, understanding that there's a spike in canceled subscription on the first of the month, that's a really good sign when you create a model that has an output like that. And you can use these sort of aggregate metrics to understand how your model is performing. Okay. So going into the discovery phase, we've been creating these types of models since the end of 2020. We've created dozens of these custom models for our clients. I'm going to talk through the process on the most general level. So we connect with the client, we use their API key, we get some historical data dump. Usually we use around 20,000 messages to explore it. We haven't always, but as of late, I'd say the last 2 or 3 years, we've been using BerTopic, which is an unbelievable library. I had the honor of interviewing Martin Grutendorf for the first episode of my podcast. I think everyone here would probably love it. Also, we use sentence transformers to encode the data. I'll get more into sentence transformers. Also, I happen to also interview Niels Reimers, the creator of sentence transformers, and Tom Arson, the maintainer of sentence transformers, is on the call. Hi, Tom. And then as of late, we created a way of basically making our representation layer better. So you have all of these clusters, that's great, but what is this cluster about? And you can use LLMs and simple prompts to help you summarize these clusters. I'll get more into it. And then you hope that after you do this, these topics can turn into these reasons for contact and intents. And we get these 20,000 messages, they'll be outliers. So whatever, we could say 15,000 messages with weak labels that we then put into Argilla. And we created text classification records, and we had people validate these samples. And just going into this discovery, focusing on that for a minute. So we're using topic modeling, trying to find structure in this data. So you could see on the right-hand side, you have all of these customer messages, you put it through the topic model, and then you start to get these categories like, I want to cancel my subscription, I want to cancel my order, where is my delivery? And then the bottom I just wrote, I have an obscure question, that's just like an outlier class. And then it becomes much easier for an annotator to look at a message and say, is this cancel subscription or is it not? Right? They can look at the text and you can just make a binary decision instead of having to say, okay, we found these 30 classes, here's a message, here human labeler. You have to understand every single message. You have to keep all of this in your head and you have to try to figure out what the label is. That's extremely difficult. So what we do is we generate names for topics, we generate definitions for these topics, and we have representative samples. And this creates a sort of definition for this class, and that leads into what our annotation guidelines are for when it's in Argilla and people, our annotators, are actually giving us validated samples. I think in the interest of time, I'm going to skip over this, but BerTopic is an incredible library. I encourage everyone to go check out the documentation. It's one of the best libraries that I've ever used. It has totally transformed the work that I do. The outputs are incredible. You get really amazing document visualizations like this. So every dot here represents a document. And I just generated this sort of for this demo with minimal documents, but you see semantically similar messages cluster. and form topics. And then the nice thing, some of these topics actually become intents or these contact drivers that we're looking for. So just in summary here, the output of discovery, you determine the number of classes. That alone is a win. Just to figure out, okay, you had this historical data dump. How many classes do you want to even look for? You generated names of classes, you generate definitions of classes, and you have representative samples. We then give this to subject matter experts and they approve it and they tell us if it's good, if it's not good, they can edit it, and then we use that. Then the next step is to gather labeled samples. We validate samples in Argilla. We find a small sample for each class. The nice thing about SetFit, which I'll get into, is that you only need a few samples to train. And then, of course, you need additional samples to validate the model. And the nice thing that I'm going to show on the next slide is that use similar, a feature in Argilla for text classification records, allows our annotators to build data sets really quickly. And another thing here that I want to highlight is that we input thousands of examples, right? We have 15,000, let's say, with weak labels, but we only need hundreds of labels to train and validate a SetFit model. So it's a really nice position to be in. It speeds up the process really well. It usually takes us from start to finish about 2 weeks to get a model out. So here in this example, you're given a text classification record. You have all of the potential classes that can be in, but the thing that our annotators love is that button, find similar, that's highlighted, because you can just quickly find related documents and we can quickly build data sets. It's saved our annotators hours. So you just have to add vectors to the data when you log it to Argilla, and then you can use Argilla's built-in semantic search, which is this find similar button. It's been a major time saver. Okay, getting into SetFit. I love this library. It is so elegant. And the thing that I like so much about it is that you can get a really good intuitive understanding of it fairly quickly. In our pipeline, so we're taking the outputs from Argilla. Say we have 20 classes and we got 50 or so labels for each class. We might put 12 from each class into SetFit. And what you do is you generate sentence pairs. So if the two sentences are in the same class, that's a positive triplet. If the two sentences are not in the same class, that's a negative triplet. And the optimizing function is a contrastive learning. So it's basically trying to pull things that are similar closer and things that are different further apart. And you're fine-tuning sentence transformer, a sentence transformer model. So you're taking contextualized embeddings and making them better for your problem. You then add a classification head, and it can usually be pretty simple one, like linear logistic regression, creating boundaries between these things, and then you get a classification model. This is some information on SetFit, huge fan. The lead author, Louis Tunstall, who's a great person working at Hugging Face, wrote the book on Hugging Face, natural language processing with transformers, was a guest on my podcast. Funny guy. I recommend everyone watching that too. And this is one of the visuals from the paper. And basically it's efficient few-shot learning with sentence transformers. It's a collaboration between Hugging Face and Intel. And yeah, we're using it for multi-class text classification. So why use SetFit? So yeah, I think I mentioned most of these things, but it's scalable, it's fast to train. SetFit 1.0, thanks to Tom, was released recently with updated documentation and functionality. I'm just scratching the surface on it, and everything that I've seen I've loved so far. What's really great is no prompting required. You don't have to fight with an LLM to try to get it to classify something. You can just quickly train it. You get high performance achieved with few examples. It's elegant, it's intuitive, and it's supported by Hugging Face. Okay, so this is a simplified visualization for supervised text classification. So when a new message comes in, it goes through the model and you get a probability for each class. You get some score assigned to each class. What we do is we then do batch inference. We run on a holdout data set to examine the classifier on the message level, create classification reports, create confusion matrices, and we do error analysis. We examine the outputs with probabilities in Argilla. I'll show an example in the next slide. If the model version passes our message level criteria, so depending on the use case, you want your precision to be probably above 0.8, because that gives you the perception that most of the time your predictions are correct. Then you have to run it on unseen conversation data to examine classifier on the conversation level. So it's interesting, we're creating it on the message level, but really in actuality, how it's going to be used is to assign contact driver on the conversation level. So here you can see you have a text classification record. And the cool thing is that you have a probability associated with it. So if you have your probability scores, you can use Argilla to do this. You see all the numbers next to your classes. So you could see for this one, it's account inquiries with a probability of 96.2. And why this is nice is because you always need to have the ability to segment data. In this case, segmenting it by probabilities. It's just really important. Segmenting the data allows you to break it down in ways that you can then tackle your problem. You can examine specific types of errors. You could see where things are going well, where things aren't going well, and understand where your resources should go. Okay, so moving along, we are going to talk about evaluation. So you have your model. Just to remind you guys, coverage, so what % of conversations are assigned an intent. Precision, when an intent is predicted, is it correct? And frequency, does the frequency of each contact driver make sense? And as I've been saying, you have to evaluate it both on the message level and the conversation level. But there's a challenge here. When you have those unseen conversations, you don't have labels. So how do you evaluate a model on unseen data if you don't have labels? So we handle this in a couple of ways. You look at aggregate metrics. You can use human annotators. Humans are error prone. They don't scale well. They're expensive and it can be time consuming. You can also use an LLM. LLM has their problems as well. We'll talk about some of these. So what are the aggregate metrics? So we could look at coverage, intents per conversation, and class frequency. So if you look at the pie chart on the right, you can see the number of intents that are assigned per conversation. We've done research on this, and a lot of times it's more than one intent. There's more than one reason that the customer's contacting the company. So you don't always just want to predict one, but most of the time you do just want one. This is a really nice breakdown. So you want to see, so here it's like almost 48%. There's one intent per conversation, 18% is 2, 5.5 is 3. But let's say you had a large percentage of 5 or greater. You know that you're misfiring. So even knowing nothing about the ground truth, you can figure out a lot about how your model's performing, which is very interesting. We call these health metrics. They're not necessarily like performance, but it's just giving you these overall ways of understanding how your model's performing. This is a nice thing that we added with LLMs. We created a generative system that can be used to validate training data and validate predictions. So if you remember the outputs of discovery, you have a class name, a definition, and examples. So we create this prompt. Given this class name is defined as this definition with the following examples, classify the following message. There you would insert the message as yes if it is a class name and no otherwise. It's really nice. You can then use this to help you validate. Okay, I have a couple slides on thresholding, which I think are important, but I'm gonna just gloss over them because just in the interest of time. But finding the best threshold is very important. It's not straightforward for multi-class text classification. I outline a way of doing it here. If people are interested, maybe we can go back to this. But yeah, thresholding is really more of an art than a science. And the reason for that is that all errors are not equal. You have to get your hands dirty most of the time. You have to examine true positives, and false negatives. And sometimes just setting that threshold above where errors get flagrant can be enough. There's not necessarily a science to that. You have to really look at the data. Okay. In conclusion, the machine learning code in the model is actually just a small set of the larger system. Just off the top of my head, there's data acquisition, there's pre-processing, hosting, monitoring, scaling, and analyzing, and then incorporating some type of feedback. It's important to just keep this in mind. It's a whole system, right? ML ops has become this really important field, and understanding how this system is going to work in production is extremely important. So breaking down some of the learnings, so important. You have to understand the problem and the use case deeply and keep revisiting the problem and the underlying need. When you start a project, the requirements are not clear, or the requirements can be contradicting. That's inevitable, or conflicting, let's say, and you have to always revisit them. Something that we found to be very interesting in these multi-class text classifiers is that incorporating classes to ignore, not just one group of ignore, like actually finding things to ignore, like in our case, if we're looking for reasons that they're contacting, finding greetings and just ignoring them, finding where they're saying thank you and just ignoring it. Incorporating heuristics can really help. Sometimes there's some lexical patterns that you can add on top of this that really can improve performance. Threshold tuning is not easy, and it's almost always needed for multi-class problems. You don't just want to assign the highest probability class. You'll have a lot of false positives. Training a model is just a small part. The key, creating high quality data sets, can help you long term. And that's where Argilla has really just transformed the work that we're doing. Yeah, as I mentioned, we have hundreds of data sets now in Argilla that we use to train and evaluate our models. Use the learnings from other models. So something early on, we created sanity checks. It's just like an eyeball test set that you can run your model on, and you can just see, for example, some of those messages that shouldn't be assigned an intent. Just make sure your model's not doing it, not assigning one of your classes with a high probability. Segmenting data is a must when you're doing error analysis, when you're looking at the performance of classes, looking at different probability distributions, looking at different probability levels, examining certain conversations based on some metadata, looking at particular classes and looking at particular types of errors. Creating strong components is important. So in this process, there's so many aspects. So there's the pre-processing, there's training, there's batch inference, there's what I was showing you, LLM validator, there's error analysis, reporting, and monitoring. All of these muscles need to be strong. But then that leads into the next point, that you're creating a system, not a model. So if you have all of these strong components, you then have to weave them together nicely. And what I found is that the ability to modify is a requirement. So never be so set on really everything you want to have it be easily able to modify, easily able to reproduce, keep track of all of the things that you're doing. We use weights and biases to do a lot of our experiment tracking, model artifacts. And then this is a point that's important also. So automation and end-to-end is a great motivation, but you have to know your data, examine it, visualize it, explore it. And at least where we are right now, you have to include human in the loop. So I have this as future and now. We are creating more ways of having LLM assist us in this process. We started using Argilla for conversation level models. We have feedback data sets that our annotators are using, where we're looking at full transcripts. We're using Markdown for the speaker. It's like a very nice way of showing it. And then we're asking multiple questions. We show the generated outputs from our models, from LLMs. We're rating these outputs, and we're very excited because basically we're building data sets for instruction fine-tuning, I'm looking forward to getting more into distill label, but right now, yeah, we're tracking prompts, using full or parts of transcripts as context, and then crafting our desired outputs. So we're in a really good position to start fine-tuning some LLMs. Okay, takeaways. I hope everyone got a little bit of an introduction and a taste of Loris. And as a machine learning scientist, you're creating a system to help companies solve problems in industry. And I hope you got a taste a little bit of the challenges creating these client-specific models and an example of how we apply NLP. Argilla, so much gratitude for you guys. Thank you for all the work that you do. We have hundreds of data sets in there, training, validation, and testing, and building out feedback data sets, and they're awesome. And also the point, LLMs are great, but it's important to understand that they're just a solution, not the only solution. Sometimes they feel like you're using a power tool when you probably just need like a hammer. And often combining multiple approaches often yields the best results. Okay, I also want to encourage people to reach out if you have any questions, and feel free to connect with me on LinkedIn. Thank you guys so much. I also included some resources here and some links to some of the podcasts that I think you guys will enjoy. Okay, thank you guys so much.
Thank you so much, Seth, for the presentation. It was really detailed, and yeah, you explained many problems that I think that many companies have and that are not probably able to solve as well as you did. We don't have any question, but I do, but we are running out of time and we have to present another thing. Yeah, if you have any question, yeah, connect with Seth in LinkedIn, or even, yeah, you can ask him in the Argilla community meetup. So yeah, really grateful, and thank you for having you, Seth, here.
Thank you, guys.
Okay, so yeah, next thing we want to talk about one initiative that we started in collaboration with Hugging Face. And yeah, I'm going to give the mic to Danny so he can explain.
Hi, everyone. Can you hear me?
Yeah, we can hear you.
Okay. First of all, thanks so much for this amazing presentation, Seth. It's been a pleasure to see all the technical details and how you apply B pragmatically, and very glad to see the usage of Argilla and also other tools we really love like SetFit and BerTopic. So yeah, congrats on that. And thanks so much for taking the time to be with us today.
Appreciate it. Thank you.
Cool. So yeah, very briefly, I wanted to share my screen to introduce an initiative we started this week, and it's about collaborating with the community to build high quality data sets. This is related to an integration that we released a few days ago that allows you to set up Argilla space on the Hugging Face Hub and enable that anyone can sign in into that space. So that means you can essentially invite like thousands of Hugging Face users to essentially help you out to label your data. So we wanted to showcase this feature with something that we've been wanting to do for a while, and that is building a high quality prompt data set. As you might know, prompts are a really important part when you are building data sets for LLMs or when you are evaluating LLMs. So it's essentially the questions that users or applications might ask to these LLMs. So we think like building a really high quality and a data set of prompts that we really understand is key to many of the open source developments that we are seeing lately. So distill, label, and all these self-rewarding approaches, essentially what they need is prompts sometimes. So what we did is to create a mix of data sets, very well-known data sets. So most of the prompts that you will see in this Argilla space have been used for training the open source models that you see. So if you contribute to making these prompts better, you are actually contributing to the next generations of models. So I really encourage you to participate. So I'm going to show the organization that we created that is called Data is Better Together. And basically there you can find two spaces. One is about the dashboard that is tracking the community progress, and the other one is about the Argilla space itself. So maybe I can show you that directly and maybe explain a little bit more what's inside. So if you go to the space, this is essentially the space page. So if you set this up in your Argilla space, you will get a nice welcoming message telling people what the space is about. If you are a user or an organization, this will be shown here. So essentially you are like encouraging people to join your Argilla space. And the cool thing is that if they have a user account on Hugging Face, they essentially don't need to provide any password or signing up or anything. So I already did that. So I enabled access to my Hugging Face ID and so on. When you do it first time, you need to grant the rights to essentially gather your identity from Hugging Face. But once you've done that once, you just can log in inside. I'm using my username on Hugging Face, so this is essentially my Hugging Face user account. We only have one data set. We wanted to keep it really simple to contribute. So essentially, if you want to spend 5 to 10 minutes just rating prompts, you can do it. The cool thing is that you can do it with your phone as well. We've been working to make at least some sort of like responsiveness. Is not the final mobile version, but it's very cool that you can get with your phone and essentially be contributing to open data sets for AI. And the task, as I said, is we're going to be showing you prompts and we are going to be asking you to rate them. This is really subjective, but what we are looking for is essentially highly interesting prompts. So something that is challenging for the LLM, something where the intent is really clear. And this is related to Seth talk. Like really, we want something where the user intent is really clear, because when you start exploring open LLM datasets, you will see that some of those have been generated synthetically or they are parts of conversations, so the intent is not really clear. And these user messages are being used for training models. So we really want like the beginning of the conversation and something that is challenging, interesting, and consistent for an LLM. If you have doubts, you can check the guidelines here where we provide some examples and so on. But it's not that important that you get this. It's just an intuition of whether this prompt is good or bad for training models. And I say this because we are collecting overlapping annotations. So essentially, we will be able to see where people agree when a prompt is very good or very bad. And those will be used for actually building prompt data set with bad examples and, of course, with good examples that can be used for evaluation, for DPO data sets, and for generating new data. So if I start contributing, I can use my keyboard shortcuts. So, for example, this one is about code, and imagine like I had the time to read it and I say, okay, this is okay or good, and then I can move to the next one automatically and continue contributing. So for example, this one
Danny,
might be, yep.
I think that we are not seeing the screen.
Now?
Yeah.
Okay. So yeah, this is essentially the UI. So you will see a prompt, and then you will see the labels. And here you can check the guidelines that I was talking about, where we explain more or less what we understand by good or bad prompts. So essentially, you can start labeling directly with your keyboard. For example, in this case, I would say this is a good prompt. So I will continuously label and rate these prompts. And the other thing I wanted to show you, do you see the screen now?
Yes.
Organization again?
Yeah.
Okay. So yeah, just to finish, this is the dashboard. So essentially, we launched this a few days ago, and we already collected more than 3,000 responses from more than 180 people. We have a leaderboard with all the people contributing. So you can see we have many people from the Argilla team, of course, from the Hugging Face team, but also from the community at large. And what we find really interesting is that some of these users haven't contributed yet a data set or a model or anything, and they are able to contribute to AI by essentially going into this Argilla space and giving their valuable feedback. But really the most interesting thing is that this is only an experiment, and anyone can go to Spaces, create a new space, and then configure it with Argilla, and then set up the OAuth integration that we have here. So essentially, if you start pushing data into your space and you have enabled this OAuth integration, anyone on the Hugging Face Hub can go there as an annotator and can start giving feedback and help you to curate and to improve your data set. So I don't know if there are questions, but that was mostly what I wanted to share today.
Thank you, Danny. We don't have any question. And yeah, we also covered the 1 hour perfectly, just 1 minute left. So, so yeah, thank you everyone for attending today. And yeah, thank you again, Seth, for the awesome presentation, and Danny also for presenting this awesome initiative. Hopefully we will reach 50K prompts annotated. And
Yes, we'll see.
Yeah, and we'll start, the V2 version of this awesome project.
Cool.
So yeah, thank you everyone for attending today. And
thank you.
Yeah, see you in the next one.
Bye-bye.
Bye.